Hello everyone. In this video, we are discussing topic related to a topic of thermodynamics, which is isothermal expansion of an ideal gas. Now, in this topic, what we want to calculate is the total change in heat involved in the isothermal process. Means we will calculate total change in heat in isothermal in reversible isothermal process. In a reversible isothermal process. Now, the word isothermal means at constant temperature. Isothermal means at constant temperature. Means throughout the process, the temperature of the gas remains constant. So it means delta T equals to 0. This is the condition. Now, as we know that internal energy of an ideal gas is depend on temperature, which we write as that change in internal energy of an ideal gas depends only on temperature. Now, the relation we know that du, where U indicates that internal energy and du means change in internal energy is proportional to Cv times dt. So, now, if in isothermal process the change in temperature is 0, so we can write that throughout the process the change in internal energy is 0. So delta U equals to 0 for an isothermal process. Now, we know that from first law of thermodynamics that change in internal energy of a system is equal to heat supplied to the system plus work done on the system. Now, for an isothermal process, the left hand side equals to 0. So we can write that dq is equals to minus of dw. And as we know that dw equals to minus p dv. So dq becomes p dv. This is equation 3. Now, we want to calculate the total heat absorbed by the gas during an isothermal process. So we want to calculate the total heat absorbed by the gas. The heat absorbed by the gas during expansion, which is delta Q, which is integral over dq. So we can write that delta Q equals to P dV. Now from uh, ideal gas law, PV equals to nRT, where n is number of moles, R is gas constant, and P is temperature. Now for simplicity, let's take n equals to 1. So we get P equals to RT by V. Now we put this expression of P in equation 4. So we get that delta Q is equals to RT by dV by V. Now let's say the initial before the expansion of an ideal gas, the volume of the ideal gas is V1. After the expansion is V2. So we know that the integration of dV by V is ln. Putting the limits, we get RT ln V2 by V1. So we arrive at our result, which is that total heat absorbed by the gas during the expansion is RT ln V2 by V1. Now, since during the expansion, the internal energy of the gas remains constant, which means that overall energy density of the system goes down. And we know that the density is proportional to pressure. This means that during the expansion, the pressure also goes down. We can write this thing. The internal energy remain constant, but the volume increase so that energy density goes down. So this is the heat involved in isothermal reversible process. I hope you like this video, and thank you.